For almost all of human history, the night sky was the one thing you could count on not to change. The same stars, the same patterns, more or less where your great-grandparents left them. We just switched on a machine that, very politely, ends that assumption. And within its first few nights of testing, it found about 2,000 objects nobody had ever seen. This is First Signal. Today, let's talk about the Vera Rubin Observatory, what it actually is, why it's different from every telescope you've heard of, and the two long-standing mysteries it's now in a real position to settle. Let's start with what it is. Rubin sits on a mountain in Chile, and it released its first images to the public on June the 23rd, 2025, before beginning its main 10-year survey in early 2026. It carries an 8.4 meter telescope and a camera of about 3.2 gigapixels, as far as we know, the largest digital camera ever built. But the size of the camera isn't really the interesting part. The interesting part is what it does with it. Most great telescopes are essentially snipers. Hubble, James Webb, they stare at one tiny patch of sky in extraordinary detail. Rubin works the opposite way. Each single image covers an area of sky roughly 45 times the size of the full moon. It takes one about every 40 seconds. And by stitching these together, it photographs the entire southern sky over a few nights, and then does it again and again for about 10 years. Here's where it gets clever. Software lays each new image over the previous one and subtracts them. Everything that stayed the same, the fixed stars, the distant galaxies, cancels out to black. What's left glowing is only the things that moved, or brightened, or appeared since last time. Asteroids, comets, exploding stars. The system is designed to flag, at least in principle, up to around 10 million of these changes, every single night. And this is why that asteroid number matters. Roughly 2,000 new ones, in days, from a telescope that was still warming up. Over its full run, Rubin is expected to catalogue more than 5 million asteroids, likely more than every telescope in history combined. These objects were always there, crossing the solar system, some of them passing near Earth. We simply couldn't see them because nothing had ever watched the whole sky at once on this kind of cadence. It even caught one record setter, a several 100-meter rock, catalogued as 2025 MN45, spinning once roughly every 2 minutes. So I want to be careful here because the dramatic version of this story is the telescope found terrifying things. That's not really it. What it found, more honestly, is how much we'd been missing. And that's a different and, I think, more interesting, kind of unsettling. And it's the reason a lot of astronomers are quietly excited, because Rubin is now positioned to answer two questions we've been stuck on for years. The first is whether there's a ninth planet. For about a decade, a handful of distant icy worlds far past Pluto have had orbits that seem strangely aligned, and one leading explanation is a large, unseen planet out in the dark, herding them with its gravity. The honest problem, until now, has been that we didn't have a tool that could properly search for it. Rubin is that tool. A distant planet gives itself away by drifting, very slowly, against the fixed stars, and that slow drift over months is exactly what this machine is built to catch. We'll come back to Planet 9 in its own video. The second is how common interstellar objects are. We've now caught 3 pieces of other star systems passing through ours. The most recent one, 3I/Atlas, we only spotted while it was already on its way out. If small interstellar objects are actually common, and we've just been too slow to notice them, Rubin should start finding them regularly, and early enough that we'd have time to study one properly. Rubin already helped track 3I/Atlas, so this isn't a stretch, it's the obvious next step. So the next few years probably won't be about building better theories, they'll be about the sky finally answering questions we've only been able to argue about. And here's the part I keep turning over, quietly. We tend to picture discovery as going outward, probes, rockets, footprints. Rubin doesn't go anywhere. It sits on a mountain and pays attention every few nights to all of it at once. And it turns out that's enough to start redrawing the map. Not because the universe changed, but because for the first time, something down here is watching the whole thing, all the time, and refusing to look away. For thousands of years we looked up and saw a fixed ceiling. It was never fixed. It was moving the entire time, full of things crossing and falling and exploding, and we just couldn't see fast enough to notice. Now, more or less, we can. There's no single answer to wrap this in, because the survey has barely started. That's sort of the point. Over the next 10 years, this is the instrument most likely to surprise us. And when it does, when it finds the 9th planet, or the next visitor from another star, or something we don't have a category for yet, this is where we'll go through it. We'll come back to this the moment the data does. Until then, keep looking up. This is First Signal.